Something is amphoteric if it can act as an acid or a base, and that means that it can gain or lose hydrogen atoms. Actually, it's hydrogen ions. And amino acids are amphoteric. They actually have two different parts that gain and lose hydrogens. The amino group and the carboxyl group are shown here with both of their hydrogen ions in place. And this is how the structure looks at low pH. At high pH, both of those hydrogens are gone. So if you notice, both of these have lost. There's one H that can come and go on each of those, and at high pH they're both gone. Now, does that make sense? At low pH, the concentration of hydrogen ions floating around in the water is very high, so both of them will have their extra hydrogen ion in place. At high pH, the hydrogen ion concentration is low. There aren't very many of those ions floating around, so those tend to come off. They tend to float off with the water, actually. Somewhere in the middle of the pH range, the overall is neutral. We call it isoelectric. So it's not just that the hydrogen comes and goes, it's that at low pH the overall charge is positive, and at high pH the overall charge is negative. At the isoelectric pH it's neutral. So when we change the charges, when we change the pH, an amino acid it's not just a matter of the hydrogens, the charges change, and that will affect proteins as well. Proteins do the same thing because some of the R groups have aminos and carboxyl groups on them. So as you change the pH, you're changing the charges on the protein. At low pH, a protein is overall positive. At high pH, it's overall negative. But somewhere, and it depends on the protein and exactly which amino acids it has, but somewhere it has an isoelectric pH. And at that isoelectric point, also called the isoelectric point, it'll be neutral overall, and what will happen is that the protein will aggregate and forms a solid. In other words, it denatures and coagulates. The reason that this happens is that at low pH, each protein is overall positive. So when you have other proteins that are nearby of the same type that are overall positive, they repel each other. They don't stick to each other. But if you shift the pH so that they're overall neutral, then they can start sticking together.